Okay, last but not least, 648. Solve the system of equations below using the equal values method, then check your solution, which we will do by putting both of these equations into a graph and seeing if our solution is correct. What we notice here is that these are both in standard form, and we don't like standard form. We like slope-intercept form when we're trying to use the equal values method. Equal values method depends on getting one variable alone, so we're going to get y alone. So to get y alone here, I'm going to start by subtracting x on both sides. And that gets us 2y is equal to negative x plus 14. Now to get y alone, we'll divide by 2 on both sides. And that will get us y is equal to negative x over 2 plus 7. So our slope here will be negative 1/2. I'm going to actually write this in a little bit different way. Instead of saying negative x over 2, which may be confusing to some, I will say negative 1/2 x. It's negative 1/2 x plus 7, because we just divided that negative 1x, which you can always have a 1 there, by 2. And then, of course, we divided the 14 by 2. So y equals negative 1/2 x plus 7. We have a slope of negative 1/2. We have a y-intercept of 7. Okay, now for this one, we want to, again, get y alone. So what we'll start with is to add x to both sides. And that will get us 3y is equal to 26, and I'll say x plus 26. I could say 26 plus x, but it's always nice to have the x first. All right, now we're going to get the y completely alone by dividing by 3. And that will get us y is equal to x divided by 3, or if we want to put the 1 here to help us understand it better, it's going to be 1/3 x plus, and we can just say 26 divided by 3, or if we want, we can put that into Desmos if we need to simplify it. But here we have our two equations. Y equals negative 1/2 x plus 7, and y equals 1/3 x plus 26 over 3. Okay, it's not looking too pretty, but we can still do this. We have a y equals and a y equals, which means we can set this expression up equal to this expression, and we will get a what do you call it? A new equation. Okay, so I'm literally just going to copy and paste these. This is equal to this. Okay, so now I'd like to get all the x on one side. So what I'll do first is I'll add 1/2 x to both sides. What happens here is that because I'm getting rid of the negative, it's going to add to the 1/3 x over there. So we get 7 is equal to 1/2 plus 1/3. It's best to think of these not as thirds and halves, but as sixths. You may know how to expand a fraction. Basically, you get the same denominator. So here where we have the 3 in the denominator, we'll multiply both the top and bottom of this by 2 to get 2 over 6x. So I'm going to kind of show that. And then, of course, we will be multiplying this one both by 3, the denominator by 3 to make a 6, and the numerator by 3 to make a 3. So it's going to be 3 over 6 x plus 2 over 6 x plus 26 over 3. All right, so the 3 over 6 plus the 2 over 6, you might notice they're both 6, so we can continue rewriting with 7 is equal to 5/6 x plus 26 over 3. Yeah, those of you who do not enjoy fractions are probably having a tough time, but this is a very important skill to have. Okay, now we're going to subtract 26 over 3. So the first thing we'll do is we'll figure out what is 26 over 3, because that'll be useful. 26 divided by 3 is 8.6666, so we'll go with that. So we're going to replace that right there. And then we'll subtract that from both sides to help get x alone. So and really what we get is an equation that isn't harder, it's simply more math involved. So we'll do 7 minus 8.66, so 7 minus, that gets us this, so negative 1.666. As you can see, I can just keep going back to Desmos to see that. So that's going to be, that is going to be equal to 5/6 x. And last, if I want to get x alone, I'll just divide both sides by 5/6. And that will help me rewrite. I'm going to have negative 1.66 divided by 5/6. So it's negative 1.666666 divided by parentheses 5 over 6. And we get this negative 1.99999, which you may realize is just negative 2. It really rounds up to negative 2. So for all of that, we just get negative 2 is equal to x. Okay, so in our system, x equals negative 2. We can plug that back in to get the y value. Negative 2 plus 2y is equal to 14. We'll add 2 to both sides. And that will get us, that will get us 2y is equal to 16. We'll divide by 2. And that will get us y equals 8. So our solution through all this madness is x equals negative 2, y equals 8. So you can write solution is negative 2, comma 8. And when we write the two equations, when we put these two equations into Desmos, we should get a solution of negative 2, comma 8. So let's see what happens. We'll deselect everything else. And where do they cross? Negative 2, comma 8. So that's how you can validate your work. Comma, solution checks out by graphing. Hooray!